Hi there, guys. Today we're going to do differentiation of functions that have a base other than e. So same idea is we're going to have a differentiation of things that aren't the natural log. So we're going to do the first rule. We'll just go over 4 rules, do an example, couple examples together, and you should be good to go. First rule is if you are finding the derivative of a to the x power. Don't know what's going on my screen. Okay, there we go. A to the x power. So the derivative of a to the x is the natural log of a times a to the x. And we'll put parentheses around both of these just to denote that they need to stay separate. Those are two separate things. It's not a times a to the x. It's the natural log of a times a to the x. Okay. Rule 2, same thing, but this time instead of maybe having an x power, we're going to have something more. You would do the natural log of a again times a to the u power. But this time you have to account for that u, so you have to multiply by the derivative of u at the very end. Okay. And just being careful to, again, keep all these things kind of separate. You can combine these two pieces right here at the end if you wanted to, but you got to be careful you're doing that math correctly. All right, what about if it has a log instead of a natural log? Well, you're still going to turn into a fraction, so we're going to do 1 over the natural log of the base, so in this case a, times just whatever the x is. And the other rule is kind of the same thing, then 1 over the natural log of a times whatever u is, but then you take this whole thing times the derivative of u. And again, try to simplify things down as far as possible when you do that. All right, so we only have one example. We're going to do 4 smaller examples inside of those and go from there. So first one, y equals 2 to the x. I want to find the derivative of that. So y prime, let's change colors actually so we can see it better. Y prime, and this one, if you remember from our rules, we take the natural log of the base, so the natural log of 2, times whatever x, or whatever the base and the exponent were, so times 2 to the x power. And again, there's nothing really to simplify here. If you wanted to switch the order, that would be fine, but that was really essentially it. Letter B, y prime is, so again, natural log of the base, so natural log of 2, times everything, 2 to the 3x, times, in this case I have to find the derivative of the stuff on top, so the derivative of 3x is just 3, so times 3 down here at the bottom. And again, there's nothing really to combine here, so you would leave it just like that. Letter C, now we have a log, so we're not just going to be looking at the base, but now I have to make a fraction. So this one, 1 over the natural log of the base, which is 10, times cosine of x, times this time by the derivative of the cosine of x, which is negative sine of x. So now I'm going to combine these. Negative sine of x over cosine of x is tangent, or negative tangent of x. So we do negative tangent of x. Whoa. Scratch that. Of course, my tablet decides to update in the middle of this. Negative tangent of x over the natural log of 10. Good. All right, last one. A little bit more difficult here. All right, so there's a little bit more involved. So y prime equals 1 over the natural log of 3, because the base is 3, times everything that's on the inside. And then times, it has to be the derivative of all that stuff that is on the inside. So the derivative of the square root of x over x plus 5. Well, I'm going to do that separately. I'm going to treat that as u and do square root of x times x plus 5. We have a quotient. Actually, let's rewrite that, x to the 1/2. There we go. X to the 1/2 over x plus 5. So again, we have a quotient, so let's do low d high minus high d low. Low is x plus 5. D high is 1/2 x to the negative 1/2 minus high, which is x to the 1/2, d low, which is just 1. You wouldn't have to write that 1 if you didn't want to. All over low low. Okay. What I did next is I factored out a negative, or x to the negative 1/2 power. If you remember that we do that, make sure you're doing subtraction. So I'm left over with x plus 5. Put the parenthesis in there. Times 1/2 to the, just kidding, x disappears. Remember, negative 1/2 minus negative 1/2 is 0, so that goes away. Minus x to the 1/2, taking out an x to the negative 1/2, leaves you with x. Okay, and I can show you that math here. If you do x to the 1/2, look at this green stuff now, to the 1/2, minus negative 1/2. Minus a negative is plus a positive, so I'm left with x to the first power. And that's where this x right here came from. All over, go close that. Let's change this. Ooh, it's like Christmas. X plus 5 squared. Oh, I forgot a squared up here. Alright, and then I would move this down. So it's 1/2 x plus 5 minus x all over x plus 5 squared. So all of this gets moved up into this what was being multiplied by. So I just rewrite it prettier. Y prime equals 1 over the natural log of 3 times the square root of x times x plus over x plus 5 times 1/2 x plus 5 minus x all over square root x square root of x times x plus 5 squared. So now I'm just going to multiply some things together. The top is just simply still just the top, so there's nothing to do there. So y prime equals 1/2 times x plus 5 minus x all over the natural log of 3. Multiplying, notice this would be like a fraction on the bottom as well, over 1, so we multiply the square root of x times the top. The square root of x times the square root of x is just x. And then notice we have an x plus 5 on the bottom, and we have two x plus 5s on the top, so it leaves just an x plus 5 left over. Okay, and then just remember, since we have pluses and minuses on the top, we can't cancel out an x plus 5 again, so just don't do that. Every time you do that, you kill a kitten, and don't do that. Alright, I think we can actually just leave it like this. There would probably be more simplification that could be done, but I'm fine just leaving it like that. Alright, sounds good. See ya.